everyone. Welcome to the Internet of Things podcast. This is your host, Stacey Higginbotham, and your co-host,
Kevin Toffel.
And we are on episode 199 of the IoT podcast. Today, we're going to be talking about final thoughts from CES, a little bit about IoT device security, actually a lot about IoT device security. Kevin's local supermarket is implementing robots. He's really excited about that. We're going to be talking about skills for Madam A and how to get paid for them, a little bit of privacy information, and a lighting acquisition. Plus, we are going to hear from Faircom about its IoT Edge database and hear from Guido Giray, who is the Chief Digital Officer of ABB. This is the $34 billion a year in revenue company that you may not have heard of, but we're going to be talking about what he calls Maslow's hierarchy of IoT needs. It is an awesome interview. I was really impressed. I think you'll enjoy it. And now it's time for a message from our sponsor. This week's sponsor is Affero. Are you looking for an IoT platform? Figure out why Kenmore and D-Link picked Affero. Affero customers have experienced as much as an 80% reduction in time to market, 99% fewer support calls, and a 10x higher activation rate. Plus, they can reuse 90% of their work from one project to the next. To learn more, visit affero.io. That's AFERO.io. Okay, let's get this started with CES. We're going to mop up the last bits of CES trends that we saw and tested and played with, and Lord only knows what else. So, Kevin, you came back with the CES plague, so we're just going to apologize right now for any weirdness in Kevin's voice or demeanor.
Yeah, Kevin is on Sudafed for like the 5th day in a row, so we'll see how this goes.
It's going to be fun. So some things I wanted to mop up some gadget news because I covered them in various articles and possibly in the CES episode. But there were a couple things that I thought were worth mentioning. One is Schlage, which does sponsor our voicemail. They introduced a Wi-Fi lock. And, I think that's a big deal. It's part of a bigger trend towards adding Wi-Fi to as many things as possible that we saw at CES. Basically, people don't want to have a hub. So they're like, hey, can we do this with Wi-Fi or Bluetooth? Which makes sense. And Bluetooth mesh is getting better. So we're seeing more low-powered sensors and such with Bluetooth in them.
And this leads to something we've been talking about recently on the prior shows, Zigbee and Z-Wave. I mean, they're just slowly fading away from, at least on the consumer side, it seems. Like you said, people don't want a hub, or maybe they don't even know what a hub is or what the benefit is, which mainly is automation. And there are non-hub automation methods. So I don't know. The Zigbee and Z-Wave folks, I
think it'll be part of the prosumer. I mean, Amazon did put Zigbee in the Echo Plus.
Mm-hmm.
And I don't think it'll take that out. But yeah, I think if you're just casually trying to, connect some light switches to your Amazon Echo or, door locks or video cameras, you're going to try for all Wi-Fi or all Bluetooth.
Right. And out of curiosity, my take on that from a CES standpoint is not many companies were talking to me about Zigbee or Z-Wave. It was like not even part of the conversation. I'm curious, since we split up most days, did you hear companies talking about it?
Only the Zigbee Alliance, which talked about ... which is their Zigbee and Thread combination thing. So this is a deeply nerdy wireless protocol for folks. Thread was actually created by Nest way back in the day and with a bunch of other companies. And it is basically, it uses the Zigbee radio protocol. So 802.15.4. I'm always like, So it's the same underlying radio, but it has software on top that lets it do things like go directly to the internet. So it's IPv6 enabled. Zigbee is not. They're both mesh. They're both low power. So the idea is your Zigbee stuff could actually be updated, possibly, depending on the chipset, to work with Thread and vice versa.
Right.
So that's an interoperability effort. They're also trying to bring it over Wi-Fi, which, again, would help. So we'll see. That would be Thread over Wi-Fi, though, not Zigbee over Wi-Fi. It feels like that ship may have sailed, but they said there'll be products in 2020 that work with ... I looked for products in the other standards news. There's the Open Connectivity Foundation, and they have their IoTivity standard. It was Intel's effort, and then they kind of subsumed all these Qualcomm all-join engineers. And basically, I thought we'd hear from them at CES, but we didn't. So I would say to you guys, on the standard side, I'm feeling a big no.
Yeah.
the OCF guys, they say that there are products out there. There's nothing that's not a gateway, really. Maybe in 2019, we're going to see stuff, but I really am not going to hold my breath on this, y'all. So your standards are pretty much going to be Madam A, which is what we call Amazon's ecosystem, or Google, and
HomeKit.
And HomeKit and Wi-Fi and Bluetooth.
Mm-hmm.
So those are kind of different levels and layers, but for most people, those are kind of going to be what you work with and look for. So is that the bad news? That's just how the smart home has evolved. And that is where we are after CES. So back to this Wi-Fi lock. So Schlage introduced this Wi-Fi lock. Wi-Fi is a huge power suck. So that's why we hadn't seen a lot of Wi-Fi locks up until this moment. The company called Hampton Array, they make Brinks stuff. They had a Wi-Fi lock, but it had solar power in it to help offset the battery drain. If you get this Schlage Wi-Fi lock, depending on temperature, depending on a number of factors, like how often you open your door and use this, you're probably looking at maybe a 2-month lifespan on the batteries. Yeah, that's a lot of batteries, but it is Wi-Fi. The Schlage folks actually told me they thought it could last for about 4 months. I feel that's really optimistic, but maybe I'm just, I haven't tested it. It's going to be a long test, so we'll have to see.
So let's take the middle ground and say it's 3 months. My Z-Wave lock was easily 6 months. Easily. And then granted, I needed a hub for that. So it would convert kind of to get on the Wi-Fi network and communicate with everything. But I don't know. I don't know that people want to change their front door batteries every 3 months or 2 to 4 months or whatever it's going to be. But we'll have to see when the product is, in use for X amount of months, to be honest.
Yes. And it will vary. I mean, cold weather drains your batteries.
Yep.
If you've got a hard lock to close and shut, that might have some issues. And the other thing I noticed with my Zigbee and Z-Wave locks, they actually, if you didn't connect them to the hub, their batteries drained a lot faster because they were constantly trying to connect to something. So
right. I almost wish the locks would kind of be reversed in that the bolt that goes from the door where the lock is into the frame of a door, that it actually came through the frame into the door, because then you could actually wire it.
Oh, that's a really interesting idea.
Yeah, I don't know if it's as secure, but I can't see why it would be any different.
All right. We'll see if you work in the lock industry and have thoughts on that, give us a call. I mean, that would be something you'd have to build in. That would be kind of a pain to retrofit.
Yeah. That's not an easy retrofit project. You'd have to take your whole door frame out.
Although at CES, I talked to the Moen guys and they're changing the way they do plumbing in new houses. So because these they're talking about having connectivity in the showers, and that means you've got to have electricity in with your showers. So what they're doing, instead of putting electricity right behind the shower wall, they're basically putting it in a junction box where all the pipes for the shower or bathroom meet. And that's where they're trying to add the electricity to. And I thought that was kind of an interesting thing. Now, if you're doing a bathroom remodel, which is probably when you put this stuff in, you could do that fairly easily. So it's kind of an interesting thing to think about how the smart home, these connectivity elements, are changing the design of our homes. Okay, another thing that I feel like we should talk about because it's pretty freaking awesome is Chamberlain. They did a deal with Amazon. So now you can use the Amazon Key program. Actually, it's not now. It'll be later this year, the first half of this year. But what will happen is if you sign up as a Prime member for the Amazon Key program, you can actually have the Amazon delivery person open your garage door if you have a Chamberlain MyQ compatible garage door.
And that is so much better, in my opinion, because nobody is actually or technically in your house, assuming your door from their house into the garage is locked at all times.
Yes. And I'm super excited about this. One, because I live in Texas where we have huge homes and lots of people and Costco's. So a lot of people actually have refrigerators or freezers in their garage. And so imagine being able to do grocery delivery into someone's garage as opposed to leaving it on their front porch.
If only Amazon owned, Whole Foods. Oh, wait.
Although here, I will tell you guys that we get our groceries delivered on the rare occasion, or sometimes, but they always stick everything in the fridge, which is terrible if you have bananas, because then they come out brown. That is, so if you're gonna buy from the grocery store, you should not buy bananas that route.
Yeah.
Okay. That is not a smart home pro tip. That is just a general, privileged life pro tip.
That's a produce tip.
A produce tip. Thank you. So I thought that program was really interesting. There are no fees for the consumer for that. It does open up, you could deliver a lot more interesting things. You could order a larger TV or, maybe a computer. I have no idea what I would order, but I like it. And I think it's probably something I would sign up for. Whereas Amazon Key, I would not touch that with a, 12-foot pole.
I am right there with you. Even though I'm home most of the time, I still don't want Amazon Key.
Yes. Oh, I should tell you though, y'all, it is going to only go live in 37 cities. Austin is one of them. I don't know about Harleysville.
I'm thinking not, because we're not really a city. We're classified as a village.
Yeah.
The village of Harleysville is what greets you on the sign when you drive the mile stretch through.
Maybe not. Okay,
Yeah,
so
maybe not.
The other thing that I was excited about at CES was a lot of health and wearables stuff. Some of it felt like digital snake oil is how I think of this, but this idea like, oh, we'll have an algorithm and it will help you pick your best foods for your metabolism, or we have an algorithm and it will help you, I don't know, use your brain better. So those I greeted with a lot of skepticism. But I will say that I felt like we actually saw some really interesting devices that took like the last generation of devices where you're like, oh, I'm going to give you information about your steps, and took that into like, now I'm going to give you actual actionable information about your health.
Yeah, there was quite a few of those. Some of the snake oil things, I was actually having fun taking pictures of people trying them. People like sacked out in special massage chairs and wearing like a thing on their head that would massage their brain. I mean, it was kind of comical. But there's definitely been some advancements, useful advancements in this area. And I don't know if we pointed it out on the podcast prior when we were at CES, but thinking of those next gen type products, Things came out with their Move ECG watch for $129, which adds the same ECG type functionality that the Apple Watch 4 has, obviously at a much lower price. And, I thought at that price point, the addition of that to their existing line was rather smart on their part.
Yes. And we also had some smart blind news. I mention this because that is like one of the number one requests. Once you've got your lights and your locks and your video cameras, you're like, I would like to make my blinds smarter. And there have been a bunch of Kickstarter efforts that really haven't gone very far. There's also a company called My Smart Blinds. It's about $150 for that retrofit on your existing wooden slat blinds. So it's kind of expensive. But I ran into a company called Axis. And this company actually has like a little motorized thing that you attach to your existing cords. It has to be a continuous loop cord. That's the one thing that's kind of a pain. But if you have that, you attach this connected device with a motor in it, it'll actually raise and lower your blinds for you. It's $250. It's available now on Amazon. And I thought that was pretty neat. But at the same time, IKEA announced smart blinds.
Yay.
And this is about time. I went to IKEA last spring. I think it was last spring, last summer. I don't remember.
It was months ago. I remember you telling me.
It was so long ago. And they showed me these blinds and they were awesome. And they were going to be so cheap. Kevin, do you remember how much they cost?
I think they start at $113 and go up to like $180 or so, depending on the width.
So that's a little more than they told me it would cost at the time. But that's fine, because still, those are really reasonable. And these are a whole set of shades that you buy. So this is not a retrofit.
Yeah, right. And the retrofit would not work for me because I've considered it, but I buy cellular shades with no cord. So there's no way I can retrofit. There's nothing to wind or unwind if I added a motor there. So I may go look at the IKEA blinds, or the shades rather.
There you go. So yeah, smart blind world finally opening up. Woo! I mean, I know this is a silly thing to get excited about, but I guarantee you a lot of people are going to be excited.
Yeah, I don't think it's silly because most of the smart blinds to date, you're starting at like $300 a window.
Yeah, it's very expensive.
Mm-hmm.
And if you want to go like crazy higher end shades, or you have a lot of fabric to move, then you're looking at like, I'll tell you guys, I have these like 10 by 14 feet windows. My shades, the Somfy shades I have are like $10,000 a window. I mean, it is ridiculous.
Wow.
Yeah. And I had to spend an extra, I think it was like $600 to get a retrofit, like the special proprietary radio to Z-Wave converter.
Mm-hmm.
That is not my favorite device. Somfy did actually announce a hub that does their proprietary to Wi-Fi converter. So now that exists.
And I'm assuming these require the trod-free hub.
They do require trod-free.
But that's not terribly expensive.
No, I've got one. I've got one of everything. Okay. Other CES things, anything else that stuck out at you or you were like,
I hate to be, maybe it's because I'm on medicine. I hate to be the downer, But I came away from CES just kind of with a meh attitude. And yeah, there were cool gadgets, and you mentioned a bunch, and we Instagrammed a whole ton of them and talked about them on the last show. But, maybe my expectations are too high. The smart home is still not smart. I'm wondering, and this is what I wanted to see at CES, where's the predictive learning and the machine learning and AI and big data? We've been using devices for years, several years now, and all this data is collected on how we use the quote unquote smart home, but we still basically have voice control and program yourself automation. Why doesn't the home say, hey, I notice you turn your lights on within 5 or 10 minutes this time every night. Do you want me to set a routine for you? It's still very manual, and I don't understand that.
I don't either. I mean, I don't know about you, but I signed up for the Amazon Hunches, which is the closest we're getting to that so far. But I haven't actually gotten a hunch yet. There are no hunches for me.
I have a hunch it's not that exciting.
Well, maybe, but, I'd like to see it. Oh, I should mention briefly, digital assistants in cars was totally a thing.
Yes.
And I thought of that because I still haven't been invited to try out the Amazon Echo car thing. So I was like,
right.
Oh, well.
And related to what I was talking about and digital assistants, Google did announce through its hardware partner, Lenovo, a 4-inch touchscreen smart clock. It's $79. It's like the other smart displays, obviously smaller, microphone, no camera, 4-inch touchscreen, as I said, speakers, and it will actually, and this is kind of what I'm hoping to see going forward, it will suggest alarm times based on your morning and evening routines. And my hope is, since Google knows the events on your calendar, like if you've got an early meeting or something and traffic is bad, it already knows that. It can tell you that proactively. Maybe it will start using that data to suggest alarm times and such, or wake you up early.
Wake you up earlier.
Yes. See, that's a smart home. One example. That's the stuff I want to see. And that was like the only real glimpse of that I got at CES.
Yeah. Maybe next year.
I say that every year.
I was disappointed by the lack of like super deep tech. Everyone was very focused on things like 5G or smart home, like connect with Google, connect with Madam A. And that to me was like,
And that was just an extension of last year.
Yeah, I felt like I didn't see anything cool with like, I don't know, designs for better battery life. The things that I look for that are like blow me out of the water, like, oh, this actually could change the way we build products. So I didn't see any of that. I usually see some of that. I did see, so in 2017, I saw a device like that. It was a MEMS-based projector that you could interact with, and it was from Bosch. And Bosch actually productized that at this CES. So that was kind of neat. But sadly, no one else seems to be using it. So I'm kind of like, oh. Oh, well. All right. Well, that's enough about CES. Let's talk about security, which no one talked about really at CES. I didn't get a lot of security and privacy conversations personally. I don't know about you.
Nor did I. Nope.
Yeah. So this is actually more on the enterprise and industrial side, but it's chilling nonetheless. Gemalto found that nearly half of organizations, they actually can't tell if their IoT devices were breached. So this is a call for auditing you guys, which is a very important thing to have as part of your security repertoire. So Gemalto surveyed 950 IT and business decision makers for this report that they made. So most organizations consider IoT security to be a priority. Nearly 2/3, so it's 57% of survey participants said their organizations have adopted a security by design approach for creating their own IoT devices. And fewer than that, so 46% said they thought that security is the main consideration for their customers when choosing an IoT product or offering. I'd kind of go with that. Like even consumers choose based on price. Enterprises, their security is actually their top concern. So I'm not sure who these people they interviewed are. So if it's like if they're selling to a consumer market or an enterprise market, because other surveys have found upwards of 80% of enterprise users, IoT security is their biggest like barrier to adoption. So not sure there.
Yeah, security is typically right up there with enterprises, no question.
But less than 14% of these surveyed respondents' IoT budgets are going towards security. So that's not great. Yeah. And less than 2/3, so only 59% says their organization encrypts all of the data they capture or store via IoT.
That one jumped out at me. That kind of shocked me.
Yeah, so I'm a little concerned. Everybody should be storing their stuff in an encrypted format. Everybody should actually be doing security by design. And, everybody needs to have auditability so they understand, like, when things happen that they should know about. This is, I mean, it's expensive, it's hard, but if you're going to actually put sensors on everything and start gathering the data that you need and storing it, you have to protect that data.
Yeah, and I find it interesting that if security is like a number one priority, one of the easiest ways to protect the data is to encrypt it, and yet companies aren't investing the time and effort to encrypt it.
Yeah.
Duh.
Okay, well, there we go. And yeah, I don't know what else to say about that. But
yeah,
for the more advanced people who are like, encryption is not enough, let's take it a step further, the IEEE has a solution for you. And boy, howdy, it is quite the solution. So,
it is quite the name as well.
It is. So they're calling this a reconfigurable security framework for IoT. The acronym is RESIOT. The idea is you put a software-based security agent on a wireless router, a base station, or a gateway device. So you put this on somewhere in your organization so sensors can talk to this, and it basically it acts kind of as a gateway, a security gateway, yes? Gatekeeper?
Yeah, like a gatekeeper, basically. It makes sense. I mean, if you can protect everything from the router on down this way, you're in much better shape. What I don't understand, and this comes from my other hat where I write about Chromebooks, Chromebooks are secure because every Chromebook has a TPM or Trusted Platform Module, which is a piece of hardware. And that checks upon boot up every time to make sure that the system firmware has not been tampered with. If it is, basically the device will not boot. It's totally useless at that point because it's been, infected, whatever. I don't understand why routers or some type of gatekeeping devices haven't used this type of approach from a hardware standpoint, other than cost. It just makes sense.
Yeah. I mean, they say it doesn't require changes in architectures, and it doesn't, but it does require maybe a smarter router or gateway, and that's not something that people think about. And then the other thing is when you start thinking about that, you're bringing your IT system and your sensor system, which is usually an operational technology system that's been air-gapped, you're bringing those together. And that can be disturbing. So this is an architecture we see actually in industrial. So they have their sensor networks that are the OT kind of things talk to a dedicated gateway. That gateway handles security and all the information flowing up from, the machinery. And then the IT infrastructure connects down to it. And you can't it's designed so you can't have the IT stuff talk down to the sensors. It's like the design of a car should be, right? So your CAN bus and your Ethernet never actually can talk. That has been proven unsafe, as in Charlie Miller's Jeep example. But that's the idea here. And, depending on how you do it, you're actually safe or not. So take a look at this. We'll link to the story about this. It's definitely interesting. It's definitely a nice way to, maybe retrofit security into your organization, although you should still be encrypting and auditing and other things. Speaking of security, Trend Micro released a report talking about RF hacks. So this is radio frequency hacks, and it is scary as all get out. So the report's findings have found problems in cranes, drills, mining machinery, and other industrial devices produced by the 7 most commonly deployed vendors. They are a huge point of security weaknesses because they are connected, they are expensive to replace, and they are a pain to patch, and they exist in the field for a decade or more. So this research is saying that they have no rolling code, no cryptography, and no software protection. So you can have all kinds of attacks come through these. So again, encrypt. Over-the-air updates. Now, thinking about patching in industrial systems, I think we're going to actually need some new parameters around that to make it easier, because patching is not the same in a factory or a mine as it is in an IT organization. But still, we got to fix this.
It's no treat in an IT organization either. I used to do that. Yes, but it is easier.
You could lose billions if you shut your factory down by accident during a patch.
Yep.
It's a pain when your computers go down. Don't get me wrong. Mm-hmm. Okay, as anyone can tell you, who's been flying and the airline's computers go down and you're like, ah! Okay, so let's move off of security and scary things and talk about fun things like, Kevin, your supermarket is implementing robots?
Yeah, which could be scary, but the supermarket is adding big googly eyes to this robot so it looks very approachable and whatnot. The chain of supermarkets is called Giant. It's Giant Supermarkets, which is based in Pennsylvania. They have few hundred stores, not just in Pennsylvania, but They are implementing robots in their stores. The robot is made by Badger Technologies. It's rather tall. It doesn't look like a robot. It kind of looks like a big stalk on a base that just kind of roves around. And that's why they put the face on it, so it doesn't look weird. And it has LiDAR in it. It can map and navigate the store. It's got high-res 3D depth cameras for navigation and data acquisition. Basically, this thing can run for 12 hours on a charge. And what it does in the store is it looks for tripping or slip hazards on the floor, which could be, anywhere and they don't want anybody to hurt themselves.
Or
but
a
it can
lawsuit.
also, or a lawsuit, yeah. But it can also read unit tags and recognize if things are out of stock on the shelf and then alert employees when those items are available in the stockroom for restocking. So it doesn't have arms. It's not going to restock for you, unfortunately. And it also can scan the prices and make sure by checking the prices against what's on the shelf versus what's in the register database if the prices are accurate. So it can actually let people know, hey, we need to update this tag. It doesn't seem to be really taking the place of any people, which I think is a good thing. But it seems, a useful way to gather data and compare data to make sure that the shopping experience is, best as it can be. So I am looking forward. I will take photos or video of this thing when I see it.
Awesome. And chase it down.
Well, hopefully it doesn't move too fast.
Oh, okay, fair. Okay. Yeah. And next up is, hey, Kevin, is there money in creating custom Madam A skills?
Well, I wouldn't think so. But then I just read this article on Axios saying that the New York Times is planning to make money building Madam A skills. And I'm kind of surprised that they're getting into this. Basically, the Times is going to create custom skills for advertisers and sell these through a white label service. And they're not making any money after they've created the skills. There's no kickback on the ads or anything like that. It's just, we build it, you take it and go. And I'm really surprised. They have 175 people dedicated to this. And they're expecting it'll take about 3 months per skill to make a custom skill. And I guess I don't know what they're charging for it, but I'm just shocked.
Oh, it's like an ad agency kind of service.
It is, but did you expect the Times or somebody to do this? I did not.
They try anything once. I'll give them that. Journalism is a terrible industry to be in right now. So you've got to make money where you can.
Yeah.
So, yeah, we'll see.
Maybe I'll do it. Not for the Times, but for myself.
Let's talk about this hack that you found to protect my private conversations from my Google Home or my Amazon Echo.
Yeah, we've heard a number of stories and people's valid concerns about how these microphones are always listening, and somehow every once in a while the private conversations aren't so private. And there are two people that created this, I'll call it a hack, basically, because that's what it is. This hack under the name Project Alias. And what Project Alias does or will do, it's not ready for prime time yet, it will literally create white noise for the speaker until you say the keyword. And because of this, it will not hear your private conversations in a sense. The white noise will kind of balance that or negate that out. I think that's brilliant. Yeah. And I mean, honestly, one of these two companies that we're talking about, Amazon or Google, should really buy it because they should implement it themselves at the device level.
Well, so what's interesting is I'm less concerned about Amazon or Google hearing my stuff all the time. I am more concerned about someone hacking my microphones in those devices to listen in, if that makes sense. So this would actually protect against that sort of hack.
Correct.
Yeah, I'd be all about that. So, but it's not out yet, so we should just go check it out. It is Project Alias.
Project Alias.
All right, we'll link to it. Okay, we got a little acquisition news for everybody in the lighting world. You guys know how much I love my Lutron gear. Yay! They do not advertise. I just love them. And they acquired an outdoor lighting company called Limelight. The purchase price wasn't disclosed, but we should be able to, my hope is we could get awesome outdoor lighting tied into the existing lighting controls offered by Lutron. And voila, we have integrated lighting all over our home for everyone. It'll be amazeballs. So it's just a tiny little thing, but worth noting. And that's probably sufficient for the news this week. I'm sure there's a bunch we didn't cover because, good Lord, so much news. But that's the stuff we cared about. So let's take a moment to go to our voicemail. This week's voicemail is sponsored by Schlage. Do not miss your chance to win a Schley Connect Smart Deadbolt. Now it is Zigbee certified with Amazon Key compatibility, so you can upgrade your smart home with the safety, simplicity, and style of Schley. And if you want us to answer your questions, please give us a call at 512-623-7424. And this week's voicemail is from Brett. Let's hear it.
Hello, this is Brent from Utah. I have a friend whose son is in a wheelchair and doesn't speak. And when he gets home from the school, he on the bus, they'd like to be alerted, they being the parents, would like to be alerted that he's arrived home. They'd love to put something on the wheelchair that is either Wi-Fi or Bluetooth enabled or something that would alert them when the bus has arrived or the child's arrived, so that they can meet him and or know that he's safe. So do you have any ideas? We've looked into tile and a few other options, just didn't seem to alert remotely and at the distance that we wanted. Thanks.
Oh, I like this use case. It's very practical. I love those practical use cases so much. And we have a really easy solution for you. It is going to cost, and it's going to have a subscription cost, but it is the Samsung SmartThings LTE tracker.
Yes, this was announced a couple months ago. We saw it on the FCC database before they even announced it, and it is official. You can buy it on the Samsung site. It's $99.99 for the tracker. It has GPS, LTE. It's water resistant, so I think it's perfect for, attaching to the wheelchair or any similar device that somebody wants to track for people. It does have a subscription, as you mentioned, Stacy, but for the first year, that's actually included. So the cellular service is included for first 12 months. After that, it's $5 a month or $50 per year, which I think, this is a very important use case. I think it's probably worth the cost in this case for Brett.
It's a high value use case, monitoring your kid.
I don't believe you need a SmartThings hub with this because it does require the SmartThings app. And that indicates to me that you can get push notifications when the wheelchair, gets into the geofenced home area, etc. And there's no hub needed there. So I think you're fine with just this tracker and the app.
I don't know if your friend's son has a phone, but if they do have a phone, then you can use IFTTT. So IFTTT. And basically load the app on the phone and then create an applet that basically when the phone gets within Wi-Fi range of the home, it will send a notification, send a text to someone. So this is an option that is completely free. It's going to have some downsides such as latency. It may also be a little weird depending on the Wi-Fi radius. So it may trigger a little early or maybe a little late. And if there's no Wi-Fi network, like the phone doesn't have the Wi-Fi network turned on, that's not going to work. So that is an option for people who just want to track this that way and who also have a phone.
Right. There's no fee involved at that point.
Yes. All right. So that concludes this portion of the show. Stay tuned for Guido Giray, who is the Chief Digital Officer of ABB. They make everything from plastic zip ties to industrial robots. So this is a ginormous company, 290 factories. We did not get into, I could have talked to this man for hours, but we focused on his Maslow's hierarchy of IoT needs and business models that might arise from basically usage-based pricing for industrial equipment. So stay tuned for that. Hey everyone, we are taking a break from the Internet of Things podcast for a message from our sponsor. This week's sponsor is database provider Faircom, and I have Evaldo Oliveira, who is here from Faircom to talk to us about their Edge IoT architecture. So the question I see a lot of people asking is, what should their IoT Edge architectures look like? You guys have actually built a database for the Edge called C-Tree Edge. So do you have any recommendations to share with our audience?
It really depends on what is needed by the business. It can be a tough thing to decide on, so we try to help by making our database as flexible as possible. For example, a user can store all the data at the edge and send nothing of that to the cloud, or it might decide it's going to send everything to the cloud. Or they can just store just the data that they need at the edge and only send a fraction to the cloud. In some cases, what they actually need is to control the data in real time. In those scenarios, we strongly recommend to push as much process to the edge, especially on the decision making that you're trying to run.
Okay, so I'm deciding between the edge and the cloud. What are some of the things I need to take into consideration?
Well, you have to consider first the technologies that you're going to adopt. Both the edge and the cloud, they are different roles that use different types of technologies and different protocols. That's pretty much what the market has been discussing as the clash between operational technology and information technology. So make sure that you adopt technologies that support different protocols, especially if there are standards already in place. There are some other things that I think it's really important to consider, like, for example, whatever database you select to persist data on the edge, this database needs to be able to provide you with flexible schema. And this is coming mainly because of the variety of data that sensors produce. Sensors really are all kinds of different types, and in many cases, the closer your database is able to handle the data that the sensor produces in native format, the better for your application. And I guess the last point here is really being able to store data, like, for example, time series information. So if the database can collect this data for you, but at the same time calculate averages and medians automatically so you don't have to go back and query the data across your data set, that speeds up your real-time decision process. In many ways, what we're talking about here is what the market knows as the NoSQL database. And we definitely believe that a NoSQL database is the best candidate for an edge database.
And some of the things that I think of as being really important for the edge would be security. How do you guys help with that?
That's a very good point. If you decide that you're going to have to transfer some of your decision-making to the edge, you're definitely going to start to have to persist data locally to run processes, for example, that go into historical data. This immediately leads to the need for encryption. That's absolutely mandatory if you're selecting some technology to persist the data on the edge. In many ways, IoT is about combining the real-time information that's being produced by machines and equipments that you're controlling. They're being measured by its digital sensors, what's so-called the operational technology, with the backend or the corporate IT department that has a centralized view of all its systems with information like historical data of orders, costs, and inventories. We can say that making sure that this information flows properly and is safely managed is probably the main goal of IoT projects.
So where can we find out more about Faircom and your C-Tree Edge database?
You can check it at our website, faircom.com/IoT.
Hey everyone, welcome back to the Internet of Things podcast. This is your host, Stacey Higginbotham, and today's guest is Guido Giray, who is the Chief Digital Officer at ABB. Hi, Guido. How are you doing?
I'm doing very well, Stacey. Thank you very much.
Okay. Just to impress everyone, I think you should tell us what ABB is and does.
So ABB is one of the world's largest industrial companies. We make technology that helps to turn electricity into motion. So we make robots, motors, control systems, circuit breakers. We are a $34 billion company with 148,000 employees, and we have been around for a little bit over 130 years.
Exactly. This is like one of those companies that you will never hear of in your day-to-day life, but they are everywhere and huge. And they're doing amazing stuff with the Internet of Things. So let's just orient people, Guido. As the Chief Digital Officer, how do you think about the Internet of Things?
Well, so first of all, Stacey, I know that you cover the Internet of Things very broadly, but I think of it really as two markets. There's a consumer Internet of Things where we talk about colored light bulbs and home alarm systems and all kinds of connected speakers and devices like that. I cover the industrial Internet of Things, which is the other part of this equation where you're talking about devices that are connected, but they're operating inside of chemical plants and factories, inside of mines, oil and gas fields. So as a Chief Digital Officer for ABB, I'm trying to inject digital technologies in every product and service we make.
That is a tall order. And I know that we have spoken about your Maslow's hierarchy of IoT. And I would love for you to break that down for people, because I think it's a good way that companies can look at IoT and kind of assess where they are and in the journey to basically making more efficient use of their people, their processes, resources. I mean, really everything.
I'd love to do that. And in fact, I'd have to explain a little bit why I came up with this construct. It's because the Internet of Things is vastly complex. There's use cases that are different, industries that are different, technology stacks, everything from the very small, right? Sensors, communicating, analytic software in the gateway at the edge or in the cloud, machine learning, drone technology. I mean, it's almost too much to get your head wrapped around. And what I found time and time again is as I was studying what various companies and customers were doing with the Internet of Things, all of a sudden, one day, sort of a light bulb went off, and I said, this looks a lot like Maslow's hierarchy of needs. And so instead of talking about having safety and food and community and then ultimately spiritual fulfillment, the Maslow hierarchy for IoT is a way of classifying all these hundreds of thousands of individual applications and essentially reduce them to really only about 5 different capabilities or levels. So let me start. The base of the Maslow hierarchy for IoT is monitoring a whole bunch of applications and nothing more than, we have this thing, we're going to put a little chip on it, it's going to be able to talk, we communicate, and it tells us how it's doing. Why do we care? Well, monitoring is actually pretty good because you can then at least go from time-based maintenance schedules to condition-based. You only have to intervene if something is about to go bang. So that's already quite beneficial because there's a lot of equipment infrastructure that's deployed. And of course, maintaining it properly is a pretty important thing. So, and downtime is expensive. So that's the base of the Maslow hierarchy. But if you can read, you can probably also write, meaning you can change values in that system. You can write to the chip that's on that device and make it behave differently. You can speed up the robot. You can make it do new things. And as a result, you can go beyond monitoring and you can enable a class of applications that I call optimization. You can make things run faster, consume less energy, be more reliable by not operating them in extremes. And of course, this all depends on what the customer wants. And as a provider of a piece of equipment whose behavior you can now affect as a supplier, this provides more value to your customers because you can say to your customer, would you like me to optimize this device for you during its operation to better serve your needs? So that means you can actually provide more value after you've sold the device or after you've sold the product.
And it feels like with monitoring and optimization, that's mostly where we are today, correct?
That's exactly right. In fact, I would argue that probably 60-70% of all the use cases you hear about are really just in monitoring, never mind optimization, because it's an easy entry point and it's very safe to just read as opposed to affecting how things now actually perform.
Got it. Okay. So now let's keep moving up that hierarchy. Where can we aspire to be?
As you know, Stacey, the world of the web has enjoyed something called A/B testing. And for websites, this has been really amazing, right? Because you can put 2 versions of a website out there, and whichever version of the website gets more clicks, do more of that. But for those people that make physical things, for companies that make motors and transformers and all kinds of electrical equipment, we put all this time and effort in R&D, and we have no idea which features our customers really use because we have no feedback loop, or at least we didn't until now. But that feedback loop that lets us monitor the characteristics of a device also tells us which buttons people do push and which dials people do turn. And all of a sudden, you get all this data back and you know which features they're using, you know which components inside of your machine wear out the fastest. You've got all this wealth of data, so you can now, for the first time, make your products better based on usage data. And I think that's really cool. So I think this is something that we haven't had before, and it's now available almost as a free byproduct of just having connectivity.
And what do you call that?
I call that product 2.0. I call this the idea that this is, you could also call it the software-defined product. But I think the notion that it's product 2.0 because this is a product which actually, based on this digital feedback loop, you keep improving, you keep iterating, you keep making a better product.
Got it. So I think that's important to hone in on because I think that changes the way a lot of business works. So we'll come back to what it means to support and make product 2.0, but let's keep moving up your hierarchy.
Okay, so now we're ready for level 4. So level 4 is all about convergence. So we're very familiar with this as consumers. We have smartphones, and while some people say, wow, the smartphone is getting expensive, well, yes and no. It's actually relatively inexpensive if you think about the fact that your smartphone means that you no longer have to buy, in many cases, a small pocket camera, or that you don't need to buy an alarm clock, or that you don't need to have a scanner. What's happened is those have become apps. Those are features that you can add. This is about convergence. So level 4 is convergence. And of course, if you have a piece of machinery and it has intelligence on it now, it can do new things. Like, for example, we make a circuit breaker, which is like every other circuit breaker, except that it has a computer inside. And now it can do things like measure the power quality coming into the plant. It can shed unnecessary loads if you want to participate in some kind of demand response where you're getting paid to throttle demand for power, for example. And those extra features, they're apps. They're apps you can download onto the circuit breaker. And so this convergence is almost like a free byproduct of having compute inside. The last one is really the changing of the business model so that, boy, if I'm now connected, I have these downloadable apps. How would you like to pay for this product? Would you like to pay for it as a one-time purchase like you've always done with maybe a maintenance contract? Or would you like to go to a subscription model where I fold in the maintenance, the remote monitoring, the remote optimization, and you just essentially end up paying a flat monthly fee, and at the end of that product's life, I replace it with another one? Or would you instead like me to charge you based on usage? Because that's another sort of free byproduct, which is, since I'm monitoring the utilization of this product anyway, I know how often it's being used. And if you like, I can work out a system whereby you pay me the more you use it. And if you don't use it as much, you pay me less. So all of these now become possible. And this is then, of course, a dialogue and a conversation between the maker of that product and the customer of that product as to which kind of model they would prefer. But those are very interesting business model innovations that the world of the industrial economy hasn't had before.
I agree. And we will talk about that. But first, let's go back to this idea of Product 2.0. Because in our previous conversation, you mentioned that Tesla is a good example of this. We're familiar with this idea that, the car is continually being updated with software and it changes. Ideally, it gets better over time. Every now and then the software breaks things, but, that's life. So with that fundamentally is a different business for a lot of companies. So if you're going to go from making a robot that you sell once, and maybe you offer a service contract or a maintenance contract for 5 years, to making a robot that is going to constantly get better and have a continuing relationship with this customer, that feels like it changes your sales cycle, it changes your warranty obligations, it changes your costs of operating or producing a product. So break down those things.
Yeah, so let's start with the customer relationship, because that's actually one of those things that is both strengthened but also potentially changed as a result. So if you have a product, and in many cases in industry, you have a complex systems business where you make something that requires integration, deployment. And in the case where that's the case, you typically work with a channel, system integrators, people that store your product and sell it on to resellers, for example, so that first of all, establishing that digital link past the point of sale is both an opportunity for the makers of those things, but also potentially perceived as a threat to the channel. So you may unwittingly put your channel at risk, or at least to make them feel threatened, because they feel like you might use this to essentially replace some of the value add that they perceive to be bringing, which is, I'll take your robot and I'll install that at the customer site. And the maker of the robot may not know where that's going because that's being done by a system integrator or some kind of engineering company. So first of all, that digital connection changes and potentially enhances the relationship. But from a customer perspective, they, of course, value this because they see value in staying connected to the company that makes the product. And I think it just essentially says, okay, well, if that's the case, that connection is going to be there. What value add does the channel then bring? It has to do that. Just like in the world of automotive, if Tesla has its own dealers or it has that digital connection, it is essentially altering the relationship that would exist if Tesla had a channel. In this case, it doesn't. But with the automakers, presumably will continue with some evolution of their dealer model, for example. So you're asking about how does it change potentially the company making it as well? Well, clearly, it's a huge shift where the R&D starts to move from hardware increasingly to software, and that sounds relatively obvious, but that's a fairly important change for companies which traditionally have relied on material science innovation, better metals, better chemistry, understanding those deep physical properties to make the product better, to now being able to do a lot of that in software. And that's a huge shift in the kind of people that we're looking to hire.
But the materials engineering still matters. And so
it still matters, but you can affect the outcome of something quite a bit in software where, of course, material science may give you that quantum leap or that improvement, but that last or that extra bit can usually be done, another, 20, 30% of optimization might be possible just from a better tuning of the various components in a complex system.
And I'm curious because you guys deal with heavy industrial equipment. And one of the, I'm not going to call it an epiphany because it wasn't quite so broad as that, but I was talking to somebody at John Deere about the right to repair issue. And that is basically as they add connectivity and software to these machines, they're forcing farmers to rely on the dealers to repair things. And a lot of people are very upset by this, and I get it. For centuries, people have bought a product, repaired it themselves, and been responsible for it after purchasing it. As we start putting software in it, the number of people who have that skill set decreases, but it also creates this new relationship that some people don't seem to be willing to give up. And this ties to, John Deere. This might be the people who used to fix your robots at various factories that may not have access to as much of the things that might be causing the problems anymore. And even in a smart home, if I'm starting to relegate some things over to software, I'm losing the ability to tweak or control it. I think this is kind of a natural abstraction that happens when you give things over to software, but I'm curious how you're, talking to your customer base or how you're thinking about that.
Yeah, no, that's a very good question. I mean, it does manifest itself in various ways. One example of that, so on the consumer side, as you know, there's been a huge debate about privacy of data, who owns the data. There's a similar type of debate happening on the industrial side or the business side of this equation, where it's really business-to-business relationships. So it's not so much that we talk about privacy, we talk about intellectual property and data ownership. Who owns what data? And of course, as all these devices increasingly are connected, we do get data back. And one of the ways that we've tried to have that debate is to say, well, first of all, we need to clarify what the different types of data are. So we have identity data, who you are. We have essentially telemetry data, which is the individual values that these machines are sending back, their temperature, energy consumption, utilization data, for example. And then finally, there's insights, which is you take all of that raw telemetry data and you turn it into trends and predictions. And clearly, the most sensitive of all of this is the identity data married to the telemetry data. Why? It's a little bit like in healthcare. And in the US, the government has embraced something called the Healthcare Information Privacy Act, which essentially mandates that identity data be stored separately from telemetry data or measurement data from patients. Because there is potentially a good use to be made of this public healthcare data, because if we analyze it better, we might be able to determine more root causes of diseases. But we can understand why people wouldn't want that individual disease information to be tied back to them, especially if it could affect insurance rates and things like that, which we used to face. So in the industrial case, there's, I think, a similar best practice to be made in the separation of data. But I think that's only part of this equation. You asked about being able to fix things and repair things. I do think as more and more devices have embedded software, then taking that individual device apart and trying to repair it yourself is increasingly difficult. But what you do find is that increasingly people want to make things work together. And that's very similar to the analogy of your smart home. You may say, I want my smart light bulbs to be controlled from my smart speaker. How do I do that? And that's the same that's happening in industry. It's not that they want to pick apart the light bulb or the speaker. The equivalent in the industrial sense would be the sensors and the actuators and the drives and the motors, but they are interested in having them become compatible. And there's a strong interest in driving towards greater standardization. And this is where the industrial world has been slow, because on the IT side, we have seen a great convergence away from token ring and FTDI and all these things towards pretty much Wi-Fi, Ethernet, IP. That has yet to happen on the industrial side.
Let's talk about business models. So one of the things you talked about was charging based on use. And I think that is incredibly fascinating. And I started out my career covering cloud computing. And that the big trend there was moving your capital expenditures in your IT infrastructure to an operating expenditure that you pay out, as needed to Amazon or Microsoft or whomever. And when I think about that, it sounds awesome, but it also changes the way that businesses are built in the creation of wealth. It's always been about building up your infrastructure historically, right? And owning things and then taking advantage of those. So like owning your own car, then you can hire it out to people if you want and make money. But if you're thinking about your car as you pay for it by use, you'll never own it. And I think that's a very big shift we're kind of undergoing. And I'm curious about your thoughts. As we change the business model, how does that change, our ideas of wealth and how we can actually build wealth up from nothing?
Yeah. So, wow, that's almost like a deep philosophical question. But let me try and start at a basis. So you mentioned cloud computing, and it's an interesting analogy, but I think we're applying that model to a factory or a warehouse or a plant it's a bit more problematic because, and we see this a little bit with respect to, say, ride sharing, and I'll explain why. So the nice thing about cloud computing is, of course, you could move the compute assets and centralize them. And as long as the work is getting done in a good response time fashion, you don't need to know or care where those servers reside. So that works well. And the reason why that works economically is that an enterprise who's using a server at 30% of its capacity, if the cloud provider says, I will host those computing loads for you, they can double up and triple up those compute loads from multiple customers and then essentially use less total hardware, whereas 3 companies using servers at 30%, good cloud provider might be able to get away with using one server and loading it up with all those compute loads. The problem in a factory is, of course, if you have a factory that's only used at 30% of its capacity, it's really hard to rent out your factory. So one of the things that we have to do when we're thinking about pay-per-use models for industrials is somebody somewhere has to own that asset. But it may not have to be the company that makes the asset. And this is where there's a very interesting economy for companies that want to own long life assets. But you could understand, for example, if ABB makes big transformers, if we wanted to rent out those transformers to customers based on a pay-per-use model, if we ended up providing that transformer, but we retain title to the asset, that asset stays on our books. If the customer doesn't start using it, that's burning a hole in our balance sheet. It becomes very expensive capital-wise. But the good news is, again, back thanks to connectivity, there are other companies who might be very happy to own assets over long periods of time, namely pension funds. Pension funds know they have long-term liabilities they need to pay out. So they're looking for big infrastructure, things that are with very stable returns. And of course, now the question is, well, how can they predict the utilization of the returns? Well, for that, we need data. So there's this interesting question around who owns an asset, who is able to use the asset, who makes that asset, and they may actually be 3 different entities. So it's a very interesting world. And all of that, we end up staying connected, or we end up keeping track with a digital web that we're weaving, which is we know where it is and how it's getting used and who owns it, so that everybody can essentially get the benefit of that sort of shared system.
Wow. I think you just blew my mind. I love it. Okay, let's go then to the next obvious question, and we'll probably end here before everyone else is just like, wait, there's too much to think about here. What are the things we need to make this sort of vision possible? Because we are still, you talked about standards, we've talked about different business models, but I'm thinking about things like, hey, we probably need some sort of assurance, security, those kind of things. So what are the technologies that we need to move up this Maslow's hierarchy?
So yes, it starts with connectivity. Of course, if we can't connect to the device, then it doesn't work. So the good thing is we got plenty of choices, everything from just good old Ethernet to Wi-Fi, Bluetooth, 3G, 4G, 5G coming. So connectivity is an increasingly solved problem. That's good. Then we need sort of standardization in the communication stack. So you alluded to that earlier. We'd have, in addition to things like time-sensitive networking, if you go a little bit higher up, you end up with protocols such as OPC UA and other ways of standardizing the data exchange as well. So that's good. Then if you go higher up, we definitely need both cloud and on-premise or fog computing. We need both. Some people think that it's all going to go to the cloud, but the problem is we have such huge amounts of data. We have latency issues, and we have sort of health and safety limits, which mean that we cannot take all of those loops of control and automation all the way back to the cloud. But a good part of it will go to the cloud, so we need it there. There we need fantastic tools to be able to analyze all this, so great machine learning, expert systems. We also need fantastic visualization tools to be able to see and make sense of all of this data, combined with augmented reality and remote visualization tools, maybe cameras enabled on drones. So it really is an unbelievable stack of technologies that need to be assembled, not to mention, of course, what you mentioned earlier in cyber, to make all of this effective. And it's almost like the moonshot of IT. It's a bit like we have to get everything well aligned, working very well to ultimately benefit from these systems and to be able to make it foolproof and plug and play and safe.
Do you think we'll be able to do that? And how long do you think it will take us?
I think we will be able to do it. And I think we'll do that by eating the elephant one bite at a time. We'll start with our monitoring applications. Then we'll go to the optimization side. Then we'll go to product 2.0. Then we'll do the convergence thing increasingly and experiment more and more with business models. So I think it's just this one foot in front of the other. We're getting better and better at this. And we see this in all walks of technology. I mean, I think when the first network connectivity technologies were made available, such as Wi-Fi and Bluetooth, your mileage would vary in terms of whether or not this would work. But increasingly, these are incredibly incredibly reliable, incredibly capable technologies, and we increasingly get even better as the time goes by.
Excellent. All right. Guido, thanks so much for coming on the show today.
Thank you very much, Stacey.
That's it for this week. Thanks so much for listening. And remember, if you'd like more IoT news, sign up for my newsletter at stacyoniot.com. We'll see you next week.